So the first part is to draw a directed graph. We probably don't need to actually draw the graph, right? I think you probably can do that. That purpose essentially is just to make sure that you get the direction right. But you can represent the graph immediately in terms of the matrix. And if you do that, so based on the information that is given, it's about the prerequisite, and there is direction. So there is a from, there is to. Here the first line says that IS200 PMSBDM have no prerequisites. If they have no prerequisite, it means that leading to these courses, there are no incoming edges. So that means it's going to be 0 all the time for these 3 courses. Now the second line, to take OAD, student must have passed IS200. So that means IS200 will be 1. So that is the only requirement. So that means that anything else is 0. So to take SE, the student must have passed OAD. So this is OAD. So then everything else is 0. To take EI, student must have passed OAD, DM, and PMSB. OAD, DM, PMSB. So it means everything else is 0. To take AA, the student must have passed IS200 and EI. So IS200 and EI, 0 otherwise. So EWS, student must have passed SE and EI. Alright, so then you would get an adjacency matrix. In this case binary, because all we care about is just the existence of the edges. Now in this case, because it's a directed graph, the matrix is not symmetrical. So that means that you have to take care as to what is the from, what is the to. Then the next part of the question says that you need to do DFS. Right, so you will be the order in which the courses are visited if DFS is performed starting from IS200. So here you're also given the specification that the vertices are listed in this order, which are, well, which is exactly the same order as the one in the matrix itself. So if that is the case, then we just follow accordingly. So if we start from IS200, so the next one is going to go, because we go from left to right, is OAD. Then OAD is going to go to SE. And SE is going to go to EWS. EWS has nothing. So we return back to SE. SE has no other neighbor. You return back to OAD, which now has another neighbor, EI. So then you go on to EI. EI has AA. And AA has nothing, goes back to EI. Now EI could go on to EWS, but already visited. So return back to OAD, no more neighbors. It goes back to IS200. And there is only one more neighbor, AA, but it's already visited. So then no more. So if there is a case, then the DFS will be IS200, OAD, SE, EWS, EI, AA. Okay. Now DFS is not guaranteed to visit all the nodes, so that's why you only visit some of the nodes, particularly those that are reachable from IS200. So now what is 3D then? 3D is assuming that a student can only take one course per term, suggest one valid topological order in which all these courses can be taken over 8 terms. Okay, so basically we are asking for one valid topological ordering. If you're asking for one, means there could be more than one. So in this case, since we already started the DFS, we can continue this to construct the topological ordering. So topological ordering is going to require a stack that is going to keep track of the sequence. So in this case, the first one to return will be EWS because we go depth first. So S200, O80, SE, EWS. By the time we get to EWS, you cannot go on further. So upon return, EWS goes to the stack, and then SE. Now we can't do O80 yet, so because we have to do AA, and then EI, and then O80, and then IS200. Now this will be what we get out of this DFS, but because topological ordering, you must visit all the vertices. So since this is not complete yet, we have to go on to the next vertex that has not been visited, and that vertex is DM. Right, DM is next on the list, and DM has not been visited, so we start another DFS from DM. DM could go on to EI, but EI was already visited before, so we don't do it again. So instead, DM immediately returns, and he goes to the stack. And the final one, the remaining vertex that has not been visited is PMSB. So then we would start another DFS from PMSB. PMSB can only go on to EI, but already visited, so it will return. Upon return, then it will go on to the stack. So in this case, you get one topological ordering, which must include all the vertices. Now in this particular case, it does include all the vertices, and we just need to check then that all the edges are pointing forward. And in this case, I suspect they do, because IS200 could go on to O80 and EI. So there is O80 here, there's EI here, DM to EI, O80 to SE and EI, okay, SE to EWS, EI to AA and EWS, AA to nothing, EWS to nothing, PMSB to EI. Right, okay. So all the edges are pointing forward, so we get one topological ordering. So Sophia, is that what you're asking for or something else?
Yeah, because the answer is different. My answer is different from the answer key, so I just wondering.
So is that your answer?
Yeah.
Okay. So the answer key could be different because there could be more than one topological ordering. So if we just ask you, produce one topological ordering, you can produce any one. Unless we ask you specifically, run this algorithm to run on this graph to get topological ordering, then it will be exactly this one. But we just need to produce one, then you can produce it any way you want. And the algorithm that we cover in the slide is only there to guarantee that you get one. If you need more than one, then you need to figure out other ways to look at how to generate the additional ones.
So would it matter if right on top of EWS, right, I put AA and then followed by SE and EI, right? Is it interchangeable, AA and SE?
As long as you don't turn any edge backwards, then it will still be valid. So
in this case, it's valid, right? SE
so
and AA I switch.
you are switching SE and AA, yeah. So between the two of them, there is no direct linkage, right? So swapping them will not change anything, yeah. So it's still valid.